Welcome back, everybody. Today we're going to talk about the quadratic formula and show some examples of it in action. Quadratic formula is used to solve any quadratic equation. As long as you are in standard form here, ax squared plus bx plus c equals 0, with a, b, and c being constants, you can plug it into this formula, negative b plus or minus the square root of b squared minus 4ac. That's all the numerator. 2a is the denominator. It's a matter of simplifying this quantity to get our answers and using the quadratic formula. So let's see this in action for number 1. 3x squared plus x minus 1. It doesn't show a 1, but it's right here. There is a 1. So our a is 3, our b is 1, and our c is negative 1. Alright, using the quadratic formula, x is equal to negative b, which would be negative 1, plus or minus square root b squared, which is 1 squared, minus 4 times the a number, which is c, which is 3, times c, which is negative 1. You got to watch your signs on these. 2 times a would be 2 times 3. And now it's just a matter of simplifying that quantity. So we have negative 1 plus or minus, and inside the radical, notice what we have. 1 squared is 1. 4 times 3 times negative 1 is a negative 12. 1 minus negative 12, positive 13 over 6. So really there's two answers here. Negative 1 plus or minus the square root of 13 all over 6. Again, these are non-decimal answers. Let's look at another one here. 2x squared minus 3x minus 8. Alright, our a is 2, our b is negative 3, and our c is negative 8. Quadratic formula, x equals negative b, which is negative 3, plus or minus square root b squared, which is negative 3 squared, which is a positive 9, minus 4 times a times c. Our c is negative 8. 2 times a would be 2 times 2. Alright. Notice at the beginning we have negative 3, which is a positive 3, plus or minus. 4 times 2 is 8. 8 times negative 8 is a negative 64. We have 9 minus negative 64, which is a positive 73. The denominator is 2 times 2, which is 4. Our final answer, the two answers, 3 plus or minus square root of 73 over 4. Notice there's a positive or a negative. Now if you wanted to find the decimal of that, you could just plug it into the calculator and get your decimal answers if you needed them. Let's look at another example. Number 3 here. 2x squared minus 7x minus 3. A is 2, b is negative 7, c is negative 3. Quadratic formula, x equals negative b, which would be a negative 7, plus or minus square root b squared, negative 7 squared is a positive 49, minus 4 times a times c, which is negative 3. 2 times a, 2 times 2. And now we're going to simplify that. Negative, positive 7. 4 times 2 is 8. 8 times negative 3 is a negative 24. 49 minus a negative 24, 73. 2 times 2 is 4. So our answer is 7 plus or minus the square root of 73 all over 4. Another example here. 2 squared minus 3x minus 5. Here's our a. Here's our b, negative 3. Here's our c, negative 5. Quadratic formula. Negative b, which is negative 3, plus or minus the square root. B squared, negative 3 squared is 9, minus 4 times a times c. The denominator is 2 times 2. and then we need to simplify. Notice again, negative negative is a positive 3, plus or minus square root. 4 times 2 is 8. 8 times negative 5 is a negative 40. 9 minus negative 40 is a positive 49. Got to remember our integers there, and that's all over 4. Now we got more simplifying here. We actually can figure out the square root of 49, unlike the other problems. 3 plus or minus the square root of 49, which is 7, all over 4. Let's keep going. 3 plus 7 is 10, so we got 10 over 4. Or we have 3 minus 7, which is negative 4, negative 4 over 4. 10 over 4 reduces to 5 over 2. Negative 4 over 4 reduces to negative 1. The two answers are negative 5/2 and negative 1. If we were to graph this equation, it would intercept the y-axis or the x-axis at 2.5 and negative 1. That's why they also call these solutions sometimes the zeros of a function. Let's look at number 5. X squared plus 15 plus 24. A is 1, B is 15, and C is 24. Quadratic formula. Negative B, negative 15, plus or minus square root. B squared, which is 15 squared. If we take 15 squared, we get 225. Minus 4 times A times C. C is a positive 24, mind you. 2 times A is just 2 times 1, which is 2. Alright, do an extra step here just to show all this work. 4, and inside the radical there, we have 4 times 24, which is a 96. So we're going to have negative 15 plus or minus the square root, 225 still there, minus 96. All over 2. 225 minus 96 gives us a square root of 129, which is not a perfect square. It doesn't reduce. We're just going to leave it square root of 129, and it's all over 2. And those are our two answers for number 5. I think I got one more to show you. Example number 6. 4x squared minus 26x minus 42. Notice the A, the B, and the C. Quadratic formula states negative B, which is negative 26, plus or minus square root of B squared. 26 squared. Well, wait a minute. Let's back up a minute. There is a way we can simplify this and make it a lot easier. You could do the quadratic formula. You could do it from here. But notice the A, B, and C, 4, 26, and 42. We can take out a GCF, make life a little easier for us. Divide out a 2. 2x squared minus 13x minus 21. Alright, that'll make our calculations a little easier. Notice the A is 2, B is 13, C is negative 21. X is equal to negative B, negative 13, plus or minus square root, negative 13 squared is 169, minus 4 times A times C, all over 2A, which is 2 times 2. Now let's simplify in the numerator. Negative 13, positive 13. 169 minus 4 times 2 times negative 22. Well, 4 times 2 is 8, and 8 times 21 is 168. And we have a negative 168. If we take 169 minus negative 168, we get a 337 positive, which is not a perfect square. It does not break down any further. We have 2 times 2, which is 4, and that is our two answers. Hopefully these examples helped you see the inner workings of the quadratic formula. Thank you for watching.